Okay, welcome Brenda and Bailey, and we'll see if we'll get others showing up. This is the week 10 webinar for this statistics class. And this is a pretty important one in terms of content. Important that it's definitely, in the top one or two most useful things that we do in statistics. And that is regression analysis. It is done everywhere. So it's done everywhere. Welcome, Jacqueline. I'm just saying we're doing regression analysis today. I want to talk about a few things that are really important coming up on the calendar. Hopefully you all know what's the big thing due on Sunday? Yeah, you're all supposed to know well. Yeah, project 2. Okay, so the project is important. I've noticed a lot of you have sent in your ideas, which is great. Make sure you look at my suggestions. Just about all of them need some tweaking here and there. One thing I want to recommend is that when you're thinking about your survey question or what your data going to collect, write down the answers to maybe one person's answer or two people's answer. And if you're not writing a number down, then it's not for project 2. Project 2 has to be number answers, either two populations and you're comparing their answers, or two questions and you're comparing the answers to the two questions. And that could be, doesn't have to be people either, it could be collecting data, for example. But you're going to be writing a bunch of numbers in the spreadsheet. And if you're not writing a bunch of numbers in column 1 and column 2 in the spreadsheet, then the project won't work. So I've noticed a few of you suggested some yes/no question stuff, and yes/no can't work. That's a couple notes about the project. If you have not already decided on your project, look at the Project 2 discussion forum, look what other people have done, look what's working, what's not working, how it got modified, and that'll give you some ideas. The other thing I want to mention, so Jacqueline and Ross, thanks for coming, Ross and Brenda and Bailey. Did you read my announcement that I sent out? That was yesterday. That was a really important announcement. So I'm hoping you all read it. Yeah, not just rough draft yesterday, on Wednesday, and that's important, but even more important, I gave you guidelines, kind of step by step in order on what the project needs to have. A lot of people struggle on what the contents of the project are. And so I was very specific on the things you need to have in your project. And you need to have all of those, and it was a long list, a list of something like 18 different things. I could look at it, but I'm pretty sure it was 18. So please take a look at that announcement. Make sure that when you do write your rough draft, you include each of those items in your draft. The other thing, as I mentioned, rough draft is, as you mentioned, Jacqueline, it is due Wednesday night. But if you do it earlier, then yours will get read first, and I'll be able to give you feedback first. So it takes me a while to read them all. So if you wait till the last minute on Wednesday night, it might be a while because I have to read through all of them, and you'll be last. So again, the earlier you do it, the sooner you'll get my feedback. Because when you send me an 8-page or 10 paper, I don't read it in 5 minutes. It takes me some time, and then I got to write out all the feedback. So again, please look at it is 18 items. Look at the 18 items I included on things that you're supposed to do for your project. Okay, there's also the project 2 guidelines, but the 1 through 18 is more specific. So are there any questions about the project? Any questions at all? Again, this is a good time. Webinar is a good time to get instant feedback and instant answers. Whereas if you send me a question, I always answer within a day, but sometimes it takes some hours. For the homework, I was getting dim error on some of the tests. I watched a YouTube video to turn my plots off, but that didn't help. So dim error. This is for the chi-squared homework, or is that what you're talking about? So for chapter 11, good as a fit. Yeah. That was hard to see unless I actually see what you put into your calculator. When you're saying you get an error, you mean when you put it in the calculator? Yeah, I'd have to actually see an example of the error you got in a calculator. There's a lot of things that can go wrong. And one of the things, for example, yeah, so one thing that's a possibility, I'm just guessing, is that possibly when you did good as a fit and you have your L1 and L2, if you don't have the exact same number of data values in L1 and L2, then it'll give you a dim error. So it's possible you forgot to put one of the probabilities in, or you skipped a line somewhere, and that'll give you a dim error. Dim means dimension. So that's my guess. That's my best guess. Again, I can only guess if all I know is you had the error, but that's probably the most likely cause of that error, is that your L1 and L2 didn't have the same pairs of numbers. You might have had a number on L1 where you didn't have one on L2. And that's never okay, because you got to have a probability for every X item. So that's my best guess. It could be something else, but that's the number one mistake I see on that particular one with a dim error. Again, it's hard for me to know exactly until I see it. But that's one thing you can look at and see if that's a problem. Okay, goodness of fit, that could happen. If you're doing the other test with a matrix, you wouldn't get a dim error. Don't think that would happen. But with goodness of fit, you can get a dim error. Okay, other questions? Here we go. Using the spreadsheet under tab 2, var stats, under the impression that we should only edit column A and B. The level of confidence and level of confidence. Yeah, that's the other thing you edit. So a big suggestion, if the spreadsheet gives you a warning, are you sure you want to change this? Don't change it, because then you're changing the programming that I did. So that's for sure. Don't change anything where there's a warning. But the confidence percent, that definitely you want to play around with and change, because you're supposed to look at the 90, 95, and the 99. And of course, column A and column 2. Column B, if you don't change that, you don't have a project. All the rest of it, I don't think you would change anything else. Just the oh yeah, one tail, two. I think I asked you. Is that one? Oh no, I don't think I do one tail, two tail on that one. I think that one's fine. I don't think you change that. You just read it. Okay. Anything else? Okay. I want to mention one more thing, and that is there is a quiz. I'm going to put in quotes quiz, a week from Wednesday. Any guess, since it's on Wednesday, what that might ask you to do? I know 2 of you already have done it. Yeah, so Proctor in particular is called the final exam information quiz. So I need to know where you're going to be taking your final exam. If it's with the same proctor that you took your midterm, then it's very simple. You basically write the same. There's nothing much for you to do. If it's different, though, you need to give me all the information. Okay, so you don't have to use the same proctor, but it's easy. If it's LTCC, then that's easy. Again, you don't have to have a proctor's name for LTCC. That's just LTCC. That's the proctor's name. You can write library if you want. So that's just a note, is that, again, if you don't give me that information, then you can't take the final, because I won't know who to send it to. And if you don't take the final, then you can't pass the class. So that's about as mandatory as it possibly gets. The test, your final, I wrote your final actually yesterday. That was my job yesterday. And I haven't taken it yet, so I got to fix any little mistakes that I might have missed. But that's the one thing. And next week in the webinar, most of the webinar will be the preparation for the final. I can spend a little bit on chapter 13. We're only doing a little chapter 13, but most of next week's webinar. We'll probably have it on Tuesday, unless I hear it's different from you guys, because I kind of do it every other Monday, Tuesday, and we're Monday now. And that seems right. So Tuesday evening seems to be the most common time where I get the most people. So hopefully that works. Any other questions before I get to new material, into chapter 12? Okay, I never remember where everybody's from. Ross, you're from Tahoe, I think. I'm not sure about the rest of you. But in terms of data collection, what is the most important data collection that ever happens in the town of Tahoe, in Tahoe? Not the town of Tahoe, but in Tahoe. And Ross, you should know because you live here, and I'm not sure about the rest of y'all. I'm looking at Jackie's, and I'm looking at, I don't see pine trees outside your window, so you might not live in Tahoe. But Ross, you should know the answer. What's the most important, what is the most important thing that happens in this town, in Tahoe when it comes to data collection? And we're gonna look at that, and we're gonna analyze it, and I'm gonna give you a little history story. Yeah, lake clarity. So what I wanna do is I wanna share what happened in around 1995, okay? I was here, we had a very important person come to Tahoe. Anyone know who came to Tahoe to look at the lake clarity and understand it? The most important person there was, period, in the world probably. And I'm not talking about my daughter, she was important too, but in terms of for everyone. Yeah, President of the United States. And at the time, that was Clinton, not Hillary, by the way. That was Bill Clinton. And so I'm going to give you a little history lesson. He actually came to Tahoe, and one of my students got to talk to him, which was kind of cool. She served him lunch. She was a waitress, and he was at the Biltmore down in the North Shore. And she actually told me about this, and this is what they showed him. Okay? And I apologize for those who don't love Tahoe, but this is our big thing, and I figured I should share it because it was the most important regression analysis that's ever happened in our entire town. And there is no even second. This is number one, and there's no number two. And that is this picture right here. So I want to mention a few things, tell you what this means. If you don't know what the word year means, then you got different issues. Okay, so you know what that is. It goes up to around 1996 or 1997, something like that. And it started around 1968. And what they've done is they put these little white things. And what this is every year what they do is they measure how far down you can see into the lake. They literally drop what's called a Siki dish, which is a white plate. They drop it down till you can't see it anymore, and then they see how far it went down. And the cool thing is this is done by the UC Davis researchers. And they don't just do one. They pick many days. Any guess on how many days they pick? Close, but 31. I really laughed when they said that. 30 is not enough, remember, according to our class. I just laughed hysterically when they said they picked 31 days. Okay, this was a while back when I talked to them. They picked 31 days. They took an average of the 31 days. And then because of that, when you are collecting an average of 31 and looking at that as your data value, what can you say about the distribution in one word? Normal. Okay? Now, you need that for regression analysis. It's actually the number one mistake that researchers make. And I'm not talking about elementary stat students. I'm talking about professors in psychology and stuff, is they don't ensure that you have a normal distribution. But the UC Davis people did. And when you have a normal distribution, then we can do what's called a full regression analysis. All right, so one thing that you do in regression analysis is you look at these values. They're not all over the place. Is there a clear trend? What do you think? Or do you think they're all over the place? Yeah, there's definitely a trend. And in fact, what I'm going to do is I'm going to draw that trend. I think I can do it like this. I can do a line, but I don't think I can make it a pretty color. Maybe I'll do a line. So you could just kind of eyeball a line. Everyone see that? Okay. Now we're going to do a little, today we're going to do more than eyeball, but for now I want to eyeball a line. This is clear. Okay, there is a clear linear trend of these data values. You ready for like the ultimate trick question? If you look at the line, then hopefully you know from a line, and this isn't the question yet, that when you want to understand a line, you want its equation, right? And when you want its equation, you want the slope and the y-intercept. Okay, the slope looks like it's about maybe 31 or so. Oh, sorry, the y-intercept looks like around 31, where it crosses the y-axis. Is the slope positive or negative? What do you think? Okay, so Jacqueline, what you missed was the words I said. This is a trick question. And this is something you got to be careful of. I won't give you this on a final, but I want to just mention this. Look at the y-axis here. 40 is down at the bottom, and 15 is up at the top. So a total trick question. I wouldn't give this on a test, but I wanted to just show this because we got to deal with it. And since this is the most important regression analysis that's ever happened in our community, I wanted to give you this one. Okay, so in particular, the slope is negative. And in fact, let's write down a few things. So what we can say, first thing, you're used to saying y equals mx plus b. I want to give you a warning about this. That's not how regression analysis letters work. We're going to have, first it's going to be a y hat. And I'll write the hat a little later. I can't do it using typing. Is equal to, they don't use mx plus b, they use a plus bx. So again, don't shoot the messenger. This is what everyone does. There is a reason, but the reason is too difficult to explain. And we put a hat there. And when you put a hat over the y, it means it's the predicted value of y. Whereas if you don't have the hat, it's the data value of y, which are different. Okay? Oh, sorry. You're looking at the wrong thing. I shared the wrong one. In fact, pretend like you didn't see that because I wanted to show that later. There we go. Thanks for letting me know. Okay, so we have this line. Now you can see the line. Sorry about that. And we say y hat equals a plus bx. Now let's write down what a is. So a is the y-intercept. And again, from looking at the line, hopefully you can see the y-intercept looks like. It's like around 31. So that's a is equal to about 31. How do you get b? Do you remember the definition of slope that you learned in basic algebra? Could have been a long time ago, but you learned it once. Kind of in words, what is a slope? Usually they use 4 words. Can you remember it? Maybe 3 words. 3 probably. Okay, rise over run. Does that ring a bell? Okay. So what we want to do is we want to find the rise over the run. Well, notice that the rise is how much y has changed. Y is going from 31, and let's go to this, let's go to 1997. Let's go to the end here. And in 1997, it looks like it was around 21. Do you see that? So the rise is negative 10 because it's gone down 10 meters in clarity. These are meters, by the way. So we're going to have a negative 10 divided by, and the run is going to be 1997 minus 1965, which is 32. Right, 1965 plus 32 is 1997. Anyone lost on what I just did? I should warn you, by the way, I should have warned you earlier. Today's one of the more mathy days. So we're doing a lot of lines. Y equals mx plus b, or in this case, y equals a plus bx is what we're going to be looking at. We're going to be looking at slope. We're going to be looking at y-intercept. So points, things like that. Okay, so what we can say now, we can put this together. And we can say that y hat, and I'm going to write it long style, y hat, so I have to draw the little hat on top, is equal to 31 minus, and that was 10 over 32 x. Any questions on that? Any questions? Okay, actually, just a note, by the way, X is a year since 1965. It's not the year. It's a lot easier to just start at 0 then. Otherwise, it's kind of weird. Okay. Any questions on that so far? All right, so now imagine you're an environmental scientist and you're talking to the President of the United States. And what you're trying to do is you're trying to convince him that we have an issue in Tahoe and we need to deal with it. So let's, just because it's fun, let's see if we can say what is the prediction of lake clarity for, how about 2019? I mean, sorry, 2019, which is now. Okay. Of course, they probably didn't care about 2019 down when they were talking about it, but we care about it. Does that make sense? So to do that, if you want to predict the lake clarity in 2019, it's very simple. What do we have to do? Or it's pretty simple. No, we're not going to change B. B is that. B is negative 10 over 32, period. It's not B. Okay, we're plugging in X. What do we plug in for X? Yeah, 2019 minus 65, which is 54, if I did in my head right. So let's see what this line predicts for today. So y of, or y hat, I guess, which means I might need more space. Y hat of 54 is equal to 31 minus 10 over 32 times 54. Yep, I did need more space. And what is that? What do you get? I'll let you put in your calculator. And while you're doing that, I'll do it too. I'll stick it in Google. So what do y'all get? Yeah, or about 14. 14 is probably good enough. Again, if you're trying to predict the future, you probably don't want to go 3 decimal places. So it's about 14. Okay, now, if you think about it, that means that lake clarity, the prediction, is predicted to go down by a significant amount, right? 14 is a disaster in our town, by the way. So that means that you can see 14 meters and that's it, when you used to be able to see, say, 30 meters in the 60s. So 14 is reduced by like half. Any questions on that? So what they did is, again, they used regression analysis and they made a prediction. Any of you know, based on that, what did Clinton do? Now it's politics, not math. I think, Ross, you live in Tahoe. I don't know about the rest of you. I'm trying to remember who else lives here. And if you know what happened? Haven't lived in Tahoe that long. Okay, so he actually put in a bill into Congress, or National Congress, to fund the cleaning up of Lake Tahoe, basically. Okay, the best management practices and environmental management, all kinds of stuff. Literally more than $100 million. Okay, huge, huge difference. And now is a Lake Clarity 14. And that was what I accidentally showed you at the beginning. I don't know if anyone noticed it. I hope you didn't, because I wanted you to be surprised. So let me show you what happened, because it's important for what we're doing. Let me go find it. That is... It is just a minute. That one. Okay, so if you look at it, are we at 14? Yeah, we're definitely not. So what happened is that they did regression analysis. They saw around 1995, 1996 that a disaster was going to happen. Then it took a few years because, you know, government always takes time. They passed a bill to deal with the disaster. And if you look, things have leveled off. So if you look from around 1997 to now, there really hasn't been any change in Lake Clarity. We're not losing. We're not gaining much either, but it's basically flat. But it does go up and down. And it did before. It went up and down. But there was an upward trend. And it goes up and down. Anyone know? Again, this isn't math. This is science. Do you know why it goes up and down, even if there's no people? Yeah, weather. Weather. Rain, up here it's snow, but you get the idea. Yeah, weather. Weather changes everything. But weather is not something that consistently gets worse or consistently gets bad, although we might have global warming. I mean, we're getting global warming, and right now they don't know exactly how that's going to affect the Lake Clarity. But weather definitely is going to change. Okay, and it changes from year to year. Okay, so, and in fact, our Lake Clarity is going to go down this year because we have a lot of precip over the winter. Okay, so the reason I want to mention that is that if you look at, if you ignore the year and you just look at the Y values, you'll notice that they vary from like 31 all the way down to around 20. Do you see that? So there's a pretty big variation. There's a pretty big variation of these data values. Do you agree? But instead of looking at everything, let's suppose instead, I'll do it with a pen. We just kind of focused on some small years. We just did it kind of shorter time spans. And we look at the variation. And variation in our class, what's our big word for variation, by the way? It's like the most important statistic of all. You should all know this, actually. What's the measurement of variation? Standard deviation. So if you look at the standard deviation, if you look at a lot of local times, you know what I mean, just a few years at a time, there's not much variation. Each of these circles, it doesn't change by more than a few meters. Do you see that? But if you look at the variation throughout all the time, it goes up and down by 10 meters or so. Is that clear? When you have that situation where looking at the localized variation versus looking at the variation globally, and there's a big drop, that percent drop is called the correlation. It's called R squared, actually. So R squared gives you the percent drop in variation when you look at just a specific small time span versus looking at the whole time. And if R squared is big, that means you have a big percent drop in variation, which means that looking at the year it means you have a good prediction by looking at the year. So the line is useful. Okay, whereas if it doesn't matter whether you look at small areas or large areas, then R squared is going to be close to 0, and the line's not very useful. Any questions on that idea? Okay, I'll let you know if you think you completely understand it, you're wrong, because it is the most difficult part of this whole chapter. But hopefully you get the idea. It's so hard, I want to give you one more example. Okay. Let's suppose you walk into an elementary school cafeteria, okay, where it's lunchtime for everybody. And what you want to do is you want to supply shoes for all the kids. Okay? You're going to supply shoes for groups, kids that are there. Do you think you're going to have to do a lot of shoe sizes or just like 1 or 2 shoe sizes if you're going to the cafeteria in an elementary school? Yeah, a lot, right? Those kindergartners are very different than the 6th graders, right? Okay? So the variation in shoe sizes for just all the kids in the elementary school is huge. Do you agree? Okay, but if you look at your y-coordinate as age or grade, let's say grade, where kindergarten is grade 0, just so we have numbers. Then if you look into one specific grade, now let's just go into, say, a 3rd grade classroom. Is there going to be a reduction in the number of type of shoe sizes that you're going to expect to need in just a 3rd grade classroom versus the cafeteria at the elementary school? Yes. And that's because we have a very strong correlation between grade level and shoe sizes in elementary school. Is that clear? Okay. On the other hand, if you try to do the same thing at college, and let's call sophomores, say, a university, and let's say sophomores were grade 0, freshmen were grade 1, juniors are grade 2, seniors are grade 3. Do you think there'd be much of a variation in shoe sizes if you went to a junior level university class versus a freshman level university class? What do you think? Yeah, you would have hardly any variation. Do you see that? Hardly any change, hardly any reduction in the variation. So if you were looking at the university grades versus shoe size, you're going to have a very small correlation and a very small R squared. If you're looking at an elementary school, you're going to have a large R squared, and the regression line would be useful. In other words, it's useful to know what grade somebody's in to guess what their shoe size is. But it's not very useful at a university. Any questions on that? Okay, so I like to give more than one example because it's a tough thing, and you are going to be expected on the final to be able to explain in a different example. It won't be that example, but you'll have to be able to explain it in the example that I give you on the final exam, in words, with sentences. So get used to writing out sentences. Got it? Any questions at all on the idea of R squared? Any questions? Okay. Since there's something called R squared, you might guess there's something called R. R is called the correlation. And the big difference between R and R squared, I know R squared is the square of R. That's true. But the main thing is when you square a number, something always goes away. What always goes away? Yeah, the negative sign. So if you're talking about R instead of R squared, then a negative R means as the X goes up, the Y tends to go down. A positive R says that as X goes up, the Y tends to also go up. An R of 0 means as X goes up, you don't know anything about Y. Nothing seems to be happening. Does that make sense? And R close to 0 is like that too. So just to let you know, if you look at, let me reshare the other example that I did. Let me go back to Zoom. Okay, is R going to be positive or negative here? What do you think? Yeah, R is negative because the slope is negative. So R and the slope always have the same sign. Because the slope being negative means as one goes up, the other goes down. Okay. Another thing is in regression analysis, you can never, ever use causative language. So what you can't say is if you're looking at a third grader instead of a second grader, then that third grader will have bigger feet for a larger shoe size than the second grader, because that's not necessarily true. Okay, you can't say that it's because of this, it will happen. You use words like tends to happen, predicted to be, right? We can predict based on this regression line that if you wait a few more years, then we predict that the clarity will go down. We can't say the clarity will go down because there are times where if you wait a couple years, the clarity went up, right? Even in this era. Do you see that? So the language you use cannot be causative. Correlation does never mean causation. Okay? There is only one way to establish causation in statistics. And we talked about that in the first week of class. Didn't you remember? Do you remember what that was? No, I know it's been a long time. What's called a control study. Does that ring a bell, those words? Okay, so let me give you an example. I read this in the news today. I just happened to be reading the news, and there it was. They found out that for women, that if they have a brighter light on when they go to sleep, they're more likely to gain weight. Whereas if it's dark when they go to sleep, they're less likely to gain weight. Okay, by the way, so if you don't want to gain weight, that might work, but it was not a control study. And in the article, they said this does not mean that there's causation. Right? It might mean that people who are about to gain weight tend to want to have the lights on. Who knows? Do you see that? We really don't know. But what we can say is that there's a tendency that the brighter it is when you're going to sleep, there's a tendency for more weight gain for women. And that was a study. It was a large study. It was like 30,000 or so people. So it was a very large study, but you don't get causation from it. And control studies are very difficult to do. It's very hard, for example, to force people to have a bright light on because they were randomly selected. And other people are forced to not have any light because they were randomly selected. So control studies are the only way to get causation, and they're often impossible. And in fact, it's truly impossible in the lake one because you can't control the year. You can't say, well, I'm going to make it 1980, and see what the lake is when we do this. You can't make it 1980. That doesn't work. So control studies don't even make any sense when it comes to when the x-axis is the year. Is that clear? Because we have no way to control what year it is today. If you think you can, let me know. You'll win the Nobel Prize and a whole lot more, actually. Okay, any questions at all on so far what we've done with regression analysis? Okay. A couple more things. Again, we have this slope and we have this y-intercept. The y-intercept is 31. And we set our 0 at 1965. Now notice at 1965, they didn't do any measurements in 1965. Do you see that? But what we can say is the best prediction for the lake clarity in 1965 is that it was 31 meters. Even though we don't know, it's our best prediction based on the line. Because remember that the y-intercept is the value of y when x is 0. X is 0 is 1965. It doesn't always make sense to talk about the y-intercept. Okay? So for example, if we do, let's say we wanted to find out weight versus height. And you came up with a regression line. Why is the y-intercept not useful? Can anyone tell me? If we're doing a regression analysis on weight versus height. Why is a y-intercept not useful? Or not meaningful might even be a better word. Why is a y-intercept not meaningful if the x is weight and the y is height? And you can definitely collect data and get a regression line. Any thoughts? Okay, so I'm not seeing it. That's a bad sign. Okay, so remember the y-intercept is when the x value is 0. And then you're going to predict y. So how many of you can tell me what the height prediction would be for someone who weighs 0? Okay, it doesn't make sense, does it? Do you agree? You can't weigh 0, exactly. It doesn't make sense to say you weigh 0 pounds. You can't weigh 0 pounds, you're not a person if you weigh 0 pounds, right? You're a nothing. So none of you weigh 0 pounds, by the way. You're not nothings. Okay, so a lot of times the y-intercept has no meaning. Sometimes it's because the x value of 0 makes no sense. Sometimes it's the y value that makes no sense. Okay? Sometimes it's the y value that makes no sense. Sometimes it's the x value. Okay? And in fact, if instead of choosing year 0 to be 1965, if I chose our system where year 0 was, 2019 years ago, then you would end up actually with a y-intercept in like 10,000 or something. And that makes no sense because you can't have 10,000 meters of clarity at Lake Tahoe because Lake Tahoe is not even that deep. Do you see that? So if x or y don't make any sense for the y, if 0 doesn't make sense for x and the y-intercept doesn't make sense for y, then the y-intercept's not meaningful. Also, if the value is if 0 is very far from the data values, it's also not meaningful. Okay, that's another reason. The slope is pretty much always meaningful, and the key is it's the rise or run. Okay, and in fact, if I go negative 10 over 32 in a calculator, let's just do that, negative 10 divided by 32, and I get about negative 0.3. Okay, so I can rewrite that, and let's do that. I think I'll do it with brush. We have our slope, which is b, is equal to negative 0.3, but you can also write that as over 1. You can always divide by 1. Okay, now the slope is the rise or run, which is a change in y, divided by the change in x. Y, in this case, is lake clarity. X is year. So what we can say is that for every 1 year, on average, the lake clarity has gone down by about 0.3 meters. Negative is down, right? And that's meaningful. Okay, and by the way, that's bad. You don't want lake clarity to go down by about 0.3 meters every year. If you don't know, 0.3 meters is about a foot. So that means that on average, in that time span, we lost about a foot every year of lake clarity. Any questions on that? It's very sad, but that's why they fixed it, because we thought we were going to go to this murky, nothing, horrible lake where you can't even see a rock down a foot down. But we still have a beautiful lake. Not as beautiful as it was in the 60s, but it's still a beautiful lake. Okay, and that's because they did something about it, because they saw this regression analysis. Any questions on this? Okay, so now I want to do this with data, so which means I'm going to give you a kind of a fake problem. So I have to, I'm going to have to erase this. Let me know if you're okay if I erase it. Last chance. And then we're going to do an example. Okay, so let's go and do another example. Let's do one with data. Okay, so here's the example. The data below show the results of a study of 9 community colleges done that look at the percentage of students at the community college who receive financial aid and the percent who are business majors. Okay. The nice thing about regression analysis is as long as you have quantitative variables, and there's 2 of them, you can always do regression analysis. Sometimes you get such a small R squared that it's not very interesting, but you can always do it. Okay. And let's do the full regression analysis. All right, so the first thing I'm going to do is I'm going to write down a hypothesis. And again, I told you that we're doing hypothesis testing the whole quarter, or the whole last half of the quarter, I mean. So the good news for you guys is H naught and H1 for our class will always be the same. Okay, so you just got to remember how to write this down. So H naught is the following. All right, now I want to ask you something. Does anyone know how to read this? And by the way, that letter before the equal sign is Greek. Anyone know how to read that? Anyone speak Greek? Anyone? I've never had anyone say yes to that one. Still, no one said yes, but you might know that letter? Okay, that letter is called rho. Okay, like row, row, row your boat. So it's the Greek letter rho, and the idea is it's the Greek for R. So we want to find out is the correlation, remember R is a correlation 0? So rho equals 0. If rho equals 0, that means they're not correlated. That means knowledge. Doesn't it mean 100? I don't know what you mean by that. 100 what's? It's definitely 0. It has a value of 100. The system of Greek numerals, maybe, I don't know. Never seen Greek numerals. I've done Roman numerals. It's possible. Yeah. Again, I don't speak Greek, but I do know that we read this as rho because I'm a statistician, so I know I know what I need to know for statistics. All right, so now we're going to have H1. We want to see if there is a correlation. Rho equals 0 means there's not a correlation. So if there is a correlation, what does that say? Rho is, I'll put the 0 here also. And what's in the middle? Yeah, not equal to. Because negative or positive, you have a correlation. Do you see that? Okay, so if the correlation is, say, 0.7, you get a correlation. As one goes up, the other tends to go up. As if the correlation is, say, negative 0.9, you have a correlation. As one goes up, the other tends to go down, and it's worthwhile. Any questions at all so far? Okay, once we have that, hopefully you all know the next thing to do to get out our calculators. So let me reshare, and let's go to our calculator. Hopefully you figured out that everything we do in this class needs a calculator, just about. All right, so what I'm going to do, and follow along if you can, the good news is everyone's got this on their calculator, is I'm going to go to Stat. You're used to that. I'm going to go to Edit. I need to clear out L2. And I need to clear out, there we go. I need to clear out L1. L1 will be the numbers I had from financial aid, which was 42. Oh, shoot. I typed the 2, it didn't take it. There we go. 42, 38. I recommend you typing along with me in your calculator. 56, 19, 40. Then we had 37, 72, 55, and 20. For L2, those were the business majors. That was 15, 17, 7, 34, 12. Then we had 15, 6, 9, and 27. Any questions so far? You're used to doing this, typing in the numbers into L1 and L2 when you have 2 columns or 2 rows. Now I'm going to go to Stat again. Now I want to remind you, we're getting really close to the end of this class. So that means when we go to Tests, we're near the bottom. So if you use the up arrow, you'll find it much faster. And what we're going to be looking at is Lin, Reg, T-test. Lin, Reg, hopefully that one you might know, stands for linear regression. It turns out I'm not going to get into the mathematics, but it's the same T that we had when we did a T-test before, it turns out. There's some deep math behind it. I'm not touching it. But you can believe me. And we're doing a hypothesis test. So I'm going to hit Enter on that. My X list is L1, so if it doesn't say that, you go second one. My Y list is L2. Frequency is 1. My hypothesis is that it's not equal to. You could also have a hypothesis of less than or greater than, but then you're not finding out if there's a correlation, then you're finding out if there's a positive correlation or if there's a negative correlation. So again, that would be something you might do too. But we want a not equal to, because we want to find is there a correlation. Reg equation, we're not going to touch that today or ever. Okay, then calculate. The nice thing is it gives us everything we want. All right, so P is P 5.02. Is that a really big p-value? No, good. You should all know that by now. You should always look for that E. E negative 4, it's 0.0005. Got it? So the p-value is 0.0005. It's very important. A is about, I'm going to round to the, maybe to 1 digit. So 1 decimal place, so about 36.9. And B is about negative 0.5. Any questions on that? So that means our Y is equal to A plus BX. I'm actually going to write this down. So y is equal to 36.9 is a minus 0.5x. The rest we're not going to use in this class. They're fun, but that's not elementary statistics. That's more intermediate or advanced stats. Any questions before I move back and do the analysis? Oh yeah, one more thing actually. There is one more thing I want to look at. R squared. R squared is 0.84. Okay, and R is negative 0.92. And by the way, that's if you take negative 0.92 and you square it, you get about 0.84. Okay, any questions? All right, so now let me go back to the problem. So first, remember our p-value is about 0.000 something, right? So what does that tell us? Is that y hat? Y hat will be the equation line. I'll get to that in a minute. Let's start with the p-value. The p-value is 0.000 something. So what do you know? Yeah, it's definitely less than any alpha you'd ever use. It's statistically significant. So that means we can write down our interpretations. And we can say there is statistically significant evidence to conclude that there is a correlation between the percentage of financial aid majors financial aid recipients, sorry, and the percentage of business majors. At colleges. Any questions on that? Any questions? Okay, now we had, if you remember, let me write it out, y hat was equal to, maybe I'm going to go to the nearest whole number because it's close enough, 37 minus 0.5 x. Okay, any questions on that? All right, so by the way, if you wanted to, like, say, let's suppose you had a place that was 50% financial aid, then x would be 50. 50 times 0.5 is 25. 37 minus 25 is 12. And you would say that our best prediction for a college that such that half the students are on financial aid is that they're going to have 12% business majors. Okay. Let me also look at the 37. Does the 37 make any sense? Can it happen? Okay, first thing, can you have a college that has 37% business majors? Can that happen? Yeah, that can happen, but what's the x value? What's the x value that we're talking about if we're talking about this number 37, which is a y-intercept? Anyone know? If it's the y-intercept, what's the x value? It's very simple. That's a hint. Yeah, it's 0. Because that's what y-intercept means. It means x is 0. Okay, if you look at the financial aids numbers, there's nothing even close to 0. Do you see that? And you don't use a regression analysis to make a prediction for something that's nowhere near the data values, right? The lowest data value is 19%. Do you see that? So I would probably say that you wouldn't try to make meaning out of the y-intercept. And that's because the y0 is too far from any of the data values. If you tried to, you would have to say that if a college had no financial aid recipients, because that's 0, then our best prediction would be 37% business majors. Do community colleges have no financial aid recipients? Doesn't really happen, not for community colleges. Okay, for private colleges sometimes, especially private for profit, but not community colleges. So you wouldn't even interpret the y-intercept in this case because it doesn't make any sense. The slope does though. So that's 0.5, and again, that's 0.5 over 1. So we can say, let's write this out, is for every increase of 1% financial aid recipients, there tends to be a decrease of 0.5% business majors. 0.5 is a half. Does that mean that if, let's say, a foundation came in and gave all this money from financial aid, does that mean that because of that, we're going to have fewer business majors at the college? Right? Our college all of a sudden has this 3-year promise grant. I don't know if you know that at LTCC. So does that mean because of the promise grant that we're going to have fewer business majors? Okay, and the answer is definitely no. Okay, the key word there is because. You can't use the word because. Remember, if you take away the BE, you get cause. Okay, and that would be a cause and effect statement. You can only use words like tend to, predicts to. Okay, any questions on that? Okay, remember that r squared was 0.84. So what we can say, let's do it in a different color so we can, that's a good color for r squared. There is a pretty big variation in business major, in the percent of business majors for colleges in general. But if we just look at colleges that all have the same financial aid, percent financial aid recipient percent, this variation on average is 84% less than the general variation, or the variation in general. Okay, so that's a pretty big drop. So that means that knowing the percent financial aid recipients at a college is very helpful for predicting what the percent business majors are, because we have a variation decrease of 84%. Any questions on this? Any questions? So I want to let you know that regression analysis is used everywhere. Let me give you, do we have any business majors in this group? Anyone's taken a business class or an econ class? Nobody's ever taken a class in business or econ? You've probably heard of supply and demand. Have you heard of that? Ah, Brenda. Okay, I need somebody. Usually I get someone. Usually a lot of people take it. So you probably get like supply curve and demand curve, and they show you the line. Do you remember that in your business class? Yeah. What they usually don't tell you in a freshman business class is how you get that line. I bet, Brenda, they didn't talk about that, did they? Yeah. Any guess on why they didn't talk about it? They just gave you the line, right? Not that it's hard to get, it's that you have to know statistics. You now can get it. So what you do is you collect data on supply and demand, and then you do regression analysis, and that'll give you the equation line. And that's how they do, that's how you find supply and demand curves. Okay, so this is really important in business. It's important in all kinds of things. Okay, not just business, but I wanted to give you that example because that's like a very concrete example that you, like I know, Brenda, you said you had it, but again, they just kind of spoon-fed it to you and you just like didn't never ask, right? But when it comes down to it, if you don't know the equation of line, it's useless to do supply and demand, right? So now we know how to find the equation of line, and this is how they do it. Any questions at all on regression analysis? All right, I need some space. So I'm going to erase something. Let me just do some erasing. I think it's that one. There we go. I'll erase some of the older stuff because I need to give you a secret word. And the secret word is line. Hopefully, from listening to the last hour and 8 minutes or so, you know that lines are important for regression analysis. What we're doing is all about the regression line. Okay. So that's, I've kind of given you, again, each of the different types of things that you have to understand in regression analysis. What I haven't given you is 12 different examples. I gave you a couple examples. You'll do more examples. I will guarantee that you're going to have a full problem on regression analysis on the final exam. Okay, and I think there's like 11 or 12 problems on the final. 2 of them are true, false, and matching. So there's really only, I think, 10 questions, but one full big question is going to be on this stuff, where you're going to have to do a full regression analysis. So make sure, I think I'm going to unshare. So make sure this week that you take the discussion post very seriously. So you're now ready for it. I never recommend, this is why I like to, one main reason I like to give the webinar early, I don't recommend doing the discussion assignment before we talk about the material because it's hard. But now you know. So what I recommend is when you go find your article, on your own article on a piece of paper, you do the full regression analysis. If you can't do it, either you don't understand it very well, or it means your article doesn't work. Okay, so that's a good test to see if your article is going to work. And again, you have a few days to, get a good article. And there's lots of articles that have regression analysis. You have to be able to find A. You have to be able to find B. You have to be able to find R squared. You have to be able to find a p-value. Okay, that's in a lot of articles, but you have to be able to get all that stuff. Okay, so that's just a note. And then post it. You've got it all written, which is good. And then you'll be able to answer someone else's easier, and I'll be able to take a look at it and give you feedback on whether you got it. It could have data. Remember, this is going to be an article, so it could have data like the last question, but it should also do some regression analysis. It better have the equation, for example. Or it better, if it shows a scatter plot, then you could actually get the equation by looking at it. If it doesn't show a scatter plot, it may not work. Most of them are going to give you a p-value. Okay? Most articles that have a scatter plot will also give you a p-value and an r squared. Those are standard. If it doesn't give you A and B, I showed you today how to find A and B. And you can eyeball it. I'm okay with that. Got it? So what you want to do, any suggestions on finding good articles, what you want to do is find something interesting. It has to be quantitative comparison, and search for that. So you can search, I mean, if don't do this because it's the one I just showed you, but you can search for lake clarity over the years, and then there's lots. Okay? But there's others that you can search for too that you might be interested in. Does that make sense? Don't search for the word regression because you're not allowed to have regression in the title. Okay, because it's not supposed to be an article on regression analysis. It's supposed to be an article that uses regression analysis. So you're going to look through, you might go through the LTCC library articles because they have p-values. Otherwise, you may have trouble finding a p-value. So you probably need a peer-reviewed one. It's not a requirement, but it helps because then they'll have things like p-values. So I would have, don't type this in for you, I would have typed in lake clarity by year or something like that. Do you see that? Or trends in lake clarity, maybe. So think about something that might, change either over time or two things that may be compared to each other, and see what you can find. Okay, and again, find an article. And LTCC's website, the nice thing is they pay a lot of money, so there's a lot of articles in that. Thousands. That make sense? Okay, and then again, this is the last full week of new material. We have another chapter. We do have chapter 13. We don't go through all of chapter 13. We just do a section or two. It's not that hard from what we're doing. Because after this week, it's time to start studying for the final. And the final is really important. High stakes. And you'll see the last discussion, I give you kind of a fun break. It's the easiest of the quarter. Okay, any other questions? Again, as always, I'm here for questions if you have them. We're in between the 7 and 7:30 time. That's always what I like to do. Make sure that you fill out within the next 9 days your final exam information, proctor information. If you're taking the exam early, then go early. Happy to have the next webinar on Monday again, if possible. Okay, I need to hear people in the Q&A form on that. So post in the Q&A, see what other people say too. Because I could do it on Monday, I could do it on Tuesday. I just thought since we did it Monday this week, maybe we'll do it Tuesday next week, but that's up to you. Proctor is due the 19th, yeah. Before the 19th. But if you're taking the exam really early, you probably want to give it to me earlier than that. So I noticed that somebody sent it because they're taking it on that Friday. They're taking it extra early. And then it helps to have a couple days for me, you know, more than a day or two to send it to make sure everything gets sent and works and all that. If you're taking it on the Tuesday or Wednesday of finals week, so that would be the 25th or 6th, then next Wednesday is fine. Okay, other questions? Again, I'm happy to answer any questions you have. Okay, have a great night, Russ. Bailey or Brenda, any questions? Did you say we can find a good... Yeah, the LTCC library article search complete, that same one you used for the last couple. Do you remember that one, Bailey? Yeah, that has a search of research articles. There's other places too, but again, we pay for this one, so you get a lot more. Okay, any other questions? Brenda, any questions? Any questions, Brenda? If I don't hear from you, I might just say goodnight. Okay, goodnight, Brenda. And for all of you watching this as an archive webinar, again, thank you for watching this. I hope to read your projects on Thursday or earlier so that I can give you some feedback. And again, it's time to start thinking about where your proctor is going to be for when you take the final exam. So have a wonderful night and take care.